Hi, this video shows how to create a custom constraint to check for objects with same name. Let's create a new project. To enable custom constraints, we need to edit the configuration file first. Just before the validate config line, put enable custom constraints to be true. Start WebGME. The local server has started. Open Firefox and go to localhost 8888 to get WebGME in browser. Create new empty project. I have saved it as test duplicates. The blue flame near the top left corner suggests that the custom constraints are enabled. Let's create a sample meta model. The model is pretty simple. It has a vertex and edge types, similar as in graph theory. Both vertex and edge are contained in drawing. Edge is the connection between two vertices. Each vertex can be both a source and destination. To create a test model, we will create a new composition view of drawing. In the test model we will have three vertices, A, B and C. Also, there are edges between vertex A and vertex B, and vertex A and vertex C. Now let us define the custom constraint. I'm saving it as check duplicates. Let us first test whether the constraint is checked or not. To run the custom constraint, click on the blue flame icon and choose to run it on this node. Check the results. Our custom constraint indeed ran correctly. Now let's build up the constraint to check for objects with same names. The first thing we need to do is to get a list of the names of children objects of the node. We can get them by using course traverse method. This method recursively visits each children of the root node, and can run a user-defined function during each visit. we will define @node function to create a list of children node names. If there is an unexpected error, we will call back to display the error. Else, we will move on to check for the duplicate object names within the list. I will define the @node function to get the child node name. The built-in getAttribute method can be used to get the name of the node. I have defined nameList as an array to store the names of all the child nodes. When the node is visited, its name is pushed into the array. Let's check whether the @node function is defined correctly. We can check it by printing out the nameList array and match the output with the test model. Let's look at the terminal output. We have 2 edges, and 3 vertices A, B and C. Usually, in the model, if the connections are not named. Hence, we will ignore adding the connection names to the nameList array. Now we just have 3 vertices in the terminal output, and they match with the test model. Now let's work on the algorithm to check for duplicates. All we need to do is search for same values in the name list array. We can use index of method in JavaScript to search within an array. The index of method returns -1, if the search element is not found. The second argument is the starting index to begin the search. In our algorithm, I am searching the value at index I, from I+1 to the end of array. Any duplicates will generate output greater than -1. Here, as you can see that there are no duplicates, all the outputs are -1. Let's change the name C to A, and check what output we get. As expected, the output of index of method for one of the node A is 2. Thus, we can use this to determine whether duplicates are present. If any of the index of method values are greater than -1, we can conclude that there are duplicate names present in the model. This is the complete constraint code. Let's check the output for the current test model consisting duplicate names. It correctly found the duplicate name. Let's change the name A back to C, so that there are no duplicates, and check the constraint. Success. We get the correct output. The custom constraint works correctly.